Something was already ending before the asteroid hit. For 160 million years, the dinosaurs had owned this planet. Not metaphorically, literally. They controlled the food, the territory, the daylight hours, the evolutionary pressure on everything else alive. If you were small, warm-blooded, and furry during the Mesozoic Era, you didn't thrive. You hid. You scavenged. You survived in the margins, in the dark, in the spaces that giants couldn't be bothered to fill. And then, 66 million years ago, everything changed in about 72 hours. But here's what I find genuinely strange about this story. The thing that most people never stop to ask: why did we make it? Not just survive the impact, but emerge from the wreckage and eventually become every mammal alive today, including you, reading this right now. What exactly did the ancestors of every dog, whale, bat, elephant, and human being have that the dinosaurs didn't? The answer isn't what you think, and it starts not with the asteroid, but with the dark. Picture the Mesozoic world at its peak. Not the Hollywood version, not swamps and volcanoes and chaos. The real version, a warm, dense, extraordinarily productive planet absolutely dominated by reptiles. The largest animals to ever walk the earth are here, eating tons of vegetation per day. The skies belong to pterosaurs, with wingspans wider than small planes. The oceans pulse with mosasaurs, and plesiosaurs the size of school buses. And somewhere, in a rotting log, a small furry creature the size of a modern shrew is trying not to be noticed. This is your ancestor. This is our ancestor. But for most of the Mesozoic, roughly the first 150 million years of mammal existence, early mammals were almost uniformly small. Most weighed less than a kilogram. Many weighed less than 100 grams. They had large eyes relative to their skulls, sensitive whiskers, and an inner ear architecture that suggests exceptional hearing in the dark. Paleontologists call this the Nocturnal Bottleneck. The theory, now supported by extensive genetic and anatomical evidence, that the common ancestor of all modern mammals was forced into nocturnality by dinosaur dominance. Think about what that means for a second. For over 150 million years, our entire lineage was essentially squeezed into the night shift. Every mammal alive today, including every human who has ever lived, is descended from creatures that spent tens of millions of years hiding in the dark. And that hiding is exactly what saved us. Hold that thought. It's the late Cretaceous. Roughly 66 million years ago, in what is now the Yucatan Peninsula of Mexico, something enters the atmosphere at approximately 20 kilometers per second. It's roughly 12 kilometers wide. The impact releases energy estimated at over 1 billion times that of the atomic bomb dropped on Hiroshima. Within minutes, material is being ejected into the upper atmosphere globally. Within hours, firestorms are spreading across North America. Within days, a layer of debris and sulfur begins to block sunlight across the entire planet. What follows is not just an explosion. It's a collapse of photosynthesis. For months, possibly years, the amount of sunlight reaching the Earth's surface drops catastrophically. Plants die. Then the animals that eat plants die. Then the animals that eat those animals. The food chain doesn't break at one link. It collapses from the bottom. And here is where the size of the early mammals stops being a liability and becomes the single most important biological advantage on the planet. A large dinosaur, even an omnivore, needs enormous caloric intake just to maintain basic function. When food sources crash, big bodies become death sentences. You can't hibernate through a multi-year nuclear winter If your metabolism demands hundreds of kilograms of food per year, you simply die. But a creature weighing 100 grams? A creature that, over millions of years of nocturnal survival, had already evolved the ability to lower its metabolic rate, to enter torpor, to survive on insects and seeds buried in the soil, seeds that would persist long after the last green plant had died. That creature had a chance. In 2013, a team of researchers led by Kenneth Angielchik at the Field Museum in Chicago published a detailed analysis of mammalian body size evolution across the Cretaceous-Paleogene boundary, the moment of the asteroid impact. What they found was striking. The burst of mammalian diversification that followed the extinction event wasn't random. It was deeply shaped by the pre-existing toolkit that nocturnal, small-bodied mammals had spent millions of years developing. The traits that made early mammals marginal during the age of dinosaurs were precisely the traits that made them resilient afterward. Thermoregulation, the ability to maintain a stable internal body temperature regardless of external conditions, meant that as global temperatures destabilized, mammals could function while cold-blooded reptiles couldn't. The biochemical investment in maintaining body heat, which had seemed like an enormous metabolic inefficiency compared to ectothermic dinosaurs, suddenly became a survival mechanism. Dietary flexibility, the capacity to eat insects, fungi, seeds, tubers, carrion, almost anything, meant that when the carefully structured food chains of the Cretaceous collapsed, mammals could adapt to whatever was available. Many non-avian dinosaurs were ecological specialists. Specialists die when their ecological niche disappears. Generalists find another way. And then there's the brain. Mammals, even the tiny ones, had proportionally larger brains than most of their contemporary reptiles. Specifically, they had more developed regions associated with sensory processing, smell, hearing, touch, because navigating the world in darkness requires processing complex sensory information rapidly. Over millions of years of nocturnal survival, the mammalian brain had been quietly, relentlessly upgraded. I find this almost poetic, honestly. The darkness that seemed like a prison was actually a laboratory. Every generation of small, furry creatures surviving another night in the Mesozoic was, without knowing it, building the cognitive architecture that would eventually produce the human brain. But that's not even the most surprising part. In the years immediately following the Chicxulub impact, the fossil record shows something remarkable. Within roughly 300,000 years, a blink of an eye in geological time, mammalian body sizes begin to increase rapidly. Species that had been constrained to small bodies for over 150 million years suddenly begin diversifying explosively, filling ecological roles that had been vacated by dinosaurs. Within 10 million years of the impact, mammals had produced animals the size of horses. Within 20 million years, the largest land mammals to ever exist were walking the Earth. This is what paleontologists call an adaptive radiation. And the Paleogene mammalian radiation is one of the most dramatic in the history of life. It's as if a coiled spring, compressed for 150 million years, was suddenly released all at once. And here's the thing about that spring. It wasn't compressed by weakness. It was compressed by competition. The dinosaurs didn't just dominate the Mesozoic. They shaped the mammals that would outlast them. Every evolutionary pressure that kept early mammals small, nocturnal, and metabolically flexible was, in the long view, a preparation. The asteroid didn't give mammals their chance. The 160 million years before the asteroid did. Think about what this story actually tells us. The mammals that survived weren't the strongest. They weren't the fastest, the most heavily armored, or the most ecologically successful by any conventional metric. By the standards of the Mesozoic, they were afterthoughts, small, nocturnal, perpetually outcompeted creatures living in the margins of a world built for something else. And yet, every mammal alive today, the blue whale, the African elephant, the chimpanzee, the domestic cat asleep in your living room, traces its lineage back to those marginal creatures. Every human civilization, every piece of art ever created, every scientific discovery ever made, including our ability to reconstruct this story from fossilized teeth and bones, all of it descends from animals that survived by being small enough to hide and flexible enough to eat whatever the apocalypse left behind. There's a biological principle buried in this story that I think matters beyond paleontology. Specialization is powerful in stable environments, but stability is never permanent. And in moments of genuine disruption, when the rules change completely and the old advantages become liabilities, the organisms that survive are rarely the ones that were winning before. They're the ones that had quietly built resilience while no one was paying attention. The dinosaurs were spectacular. They were, by almost any measure, one of the most successful groups of animals in the history of this planet. But they were built for a world that could be destroyed in 72 hours. The mammals were built for whatever came next. And 66 million years later, one particular descendant of those small nocturnal survivors is sitting somewhere, watching a video about its own origins, still carrying in its skull the enlarged sensory brain that its ancestors built in the dark. That's the part I can't stop thinking about. Nature is far more brilliant than we imagine. See you on our next exploration.